In this video, we want to use partial derivatives to show that this given function here, u is given as 1 over square root of x to the 2 plus y to the plus z to the 2, is a solution for the Laplace equation. What is Laplace equation? This equation is famous to Laplace equation. We want to prove that this function, if we take from this function partial derivative with respect to x 2 times, plus second partial derivative with respect to y, plus second partial derivative with respect to z, and we add all of these to each other, the sum of them is 0. So we have lots of things to do here. We have to find the second partial derivatives of this given function. This is not going to be an easy question. First, we are going to find ux, first partial derivative. For that, I prefer to write this given function in this form, because I don't like to use quotient rule for that expression. Probably this is going to be easier. Let's see. If we write that function in the form of u as, this is not the partial derivative, this is u. So we rewrite the given function in this form first. Now from this we are going to find the partial derivative. ux, the partial derivative would be, we bring the power down to the front, so negative 1/2 x2 plus y2 plus z to the 2 all to the power of negative 3/2. We subtract the power by 1. But is this the partial derivative with respect to x? No. Always remember chain rule. Derivative with respect to x, take derivative of the outside times by derivative of the inside. Derivative of the bracket, derivative of x2 plus y2 plus z to the 2 with respect to x. Attention, we are finding derivative with respect to x. Derivative of the inside with respect to x would be simply 2x, because derivative of x to the 2 is 2x, and derivative of other terms are 0. The 2 from numerator with 2 from denominator cancels, so the answer is, ux is, from this ux is negative x times by x2 plus y2 plus z2 all to the power of negative 3/2. Now from this expression we have to take derivative with respect to x again, because we want to find the second partial derivative. So uxx would be what? For finding derivative of this with respect to x, we have two terms. This involves x and this involves x. And as you can see, we have to use the product rule. From product rule, we know that we have to take the derivative of each multiplied by the other one. Derivative of negative x is negative 1. Very simple. So negative 1 times by x2 plus y2 plus z2 all to the power of negative 3/2 plus, put the negative x here, leave negative x, take derivative of the other part. For finding derivative of the other part, we bring the power down again, so negative 3/2 times by x2 plus y2 plus z2 all to the power of negative 5/2. And again times by derivative of x, which is 2x. So from this, we have uxx equals negative bracket x2 plus y2 plus z2 to the power of negative 3/2. These two with these two cancels. Negative 3 times negative x would be positive 3x. Times by the other x that we have, it would be 3x to the 2. So we have plus 3x to the 2. This x multiplies by this x, 3x to the 2, times by x to the 2 plus y to the 2 plus z to the 2 to the power of negative 5/2. So this is uxx. Now that we have uxx, we can do same process for finding uyy, second partial derivative of u with respect to y, and second partial derivative of u with respect to z. But is it necessary to really do all of those calculations again? Repeat same things? No, not really. Look at the function u. Function u is symmetric with respect to x, y, and z. We have a square root of x2 plus exactly y2 plus z to the 2. So, if partial derivative of u with respect to x is this expression here, can you guess what would be the partial derivative of u with respect to y? It should be negative x2 plus y2 plus z2 to the power of negative 3 over 2. When it was with respect to x, we had 3x to the 2. Now we have to have 3y to the 2. It should be this. And partial derivative of u with respect to z would be negative x2 plus y2 plus z2 all to the negative 3 over 2 plus 3z to the 2 times x2 plus y2 plus z2 all to the power of negative 5 over 2. Now that we have all the partial derivatives, we have to add all of these to each other, and we have to show that the sum of these is 0. Remember, we want to show that uxx plus uyy plus uzz equals 0. Now we have to show that the sum of these is 0. So let's see what is the sum. Uxx plus uyy plus uzz would be equal to. For adding these, please attention. We have this expression, same expression here, same expression here. So when we add these to each other, the sum of these would be negative 3 bracket x2 plus y2 plus z2 all to the power of negative 3 over 2. So the sum of these terms is this. To add this to this and this, please attention, this part is common between them. So we can factor that and we can write it as x2 plus y2 plus z2 all to the power of negative 5 over 2 times by 3x2 plus 3y2 plus 3z to the 2. When we multiply this by this, we have exactly this. 3y2 times by this would be this, and 3z2 times that would be this. So it's the same. We want to show that the sum is 0. Now look at this part. Look at the right side. We can factor a 3 from these terms because all of them have a 3. And we can factor a 3 from them, and we can put that 3 here. So let me do this here to not rewrite all of this again. So I factor 3 from this bracket. From this bracket I factor a 3 and I move it to here. You can put it here or here, doesn't matter because it's a multiplication. The order of multiplication doesn't matter. So we factor 3, 3, 3, these are going from here, and we put that 3 exactly here, this point. Now compare this bracket, please, with this bracket. These are exactly the same. The power of this is negative 5 over 2. The power of this is 1. When we have the base the same, we add this power to this. Negative 5 over 2 plus 1, negative 5 over 2 plus 1 is negative 3 over 2, because this is 2 over 2 and it's clear. So let me rewrite the first term. 2 to the power of negative 3 over 2 plus 3 times x2 plus y2 plus z2 to the power of again negative 3 over 2. We added this power to this and we got that. And it is obviously 0. The sum is 0 because this term here is negative of this term. Negative 3 times this plus 3 times that would be 0. And this is the solution of this complicated question. I hope by watching this video you have learned a little more about finding higher order partial derivatives. If you like this video, please subscribe in my channel. See you in the next videos.